Hello everyone and welcome to the Victoria Game Engine series. In today's episode we're going to be doing a tiny bit of code refactoring as well as setting up our Makefiles. Before I explain what the heck a Makefile is, let's just go into the couple of changes that I have noted myself down to have that we needed to make from the previous video that didn't quite make it into it because I had some problems with the code at first, but I have now updated and improved and now understand the code a little bit better. So the first place we're going to be going is to our vector.h file. And within this file, we are going to be looking at this line specifically here. If you remember in the last video, we set it up so that the static allocator would zero out the pointer and its whole size. Now that's fine for some data types if you have data that you're not really caring much about using. But this then eventually becomes a problem when we start using some data that we might want to keep. So for instance, if we append a whole bunch of doubles or integers into an array, they will all zero out, which is something that I missed and didn't have time to fix for the previous video. That's a very serious blunder on my part, and now I'm going to address this here by updating this line to actually do what we wanted to do. So all we're going to do is we're going to add here that to add it to p element count. So now when it's zeroing out the memory, it's going to look at the address of the pointer plus how many elements far into the array it is. Note that we assign the new element count down here. So this will be one less than the element count. So if we have the pointer pointing to, if it's only got one item in it, then p element count at this point will still be 0. So it'll just be pointer plus 0. So it'll just point to the first index in the array. And we also have to make an extra change here that it's of n size minus p size. This is another important change because we want it to be the new size of the array subtracted from the current size of the array, which we immediately change on the next line to reflect the changes we actually want to make. And that now means that it's zeroing out the first item rather than leaving it with a garbage value. Most of the time, we shouldn't technically need to do this because the majority of the time we will resize the array and then write to the position regardless. But for our case, it's important to still zero out just in case something bad were to happen and we are just resizing and nothing's added, and then we end up reading a random value we don't want to read. And with that change, that's pretty much all the changes we need to make to our code. With that out of the way, we are now able to move on to creating our Makefiles. And the first thing that we're going to be doing is we're going to create a new file, obviously under the core of our folder. I'm going to call this makefile.windows.mac, when you can hit the dot key rather than the comma. And in this file, we are going to first off start out with a comment, and we are going to first off declare some debug variables. So the main reason behind this is that when we want to compile our code, we may want to add some certain things. So when we want to compile in a debug mode or in a release mode, we'll want to specify in our makefile if debug is or isn't enabled. Now, the way you do this in Makefiles is you can declare a variable at the top of your script, and then simply when you call the command line to then run that Makefile, you can declare what value you want it to be set to. For the sake of this video, I won't be going over the absolute basics of absolutely everything with Makefiles. I will just be going over the general concepts, but I will try to explain sort of what it does when I can, if I can. So with that said, the first thing I'm going to do is I'm going to make the comment saying this is command line arguments. And what that means, and again, as I said, this is just all our command line arguments that we will specify for now that we want to have certain defines that maybe in our code exist, or certain or other things that may happen. So, or the first thing we have is we just have is debug, and by default we'll want to set this to no, so that debug is always compiling to, or that our builds are always compiling to a release build. We also want to set another flag that will not be generally affected by compiling. And this is the directory that we want to output all of our files to. And in our case, that's of course going to be our bin folder. In theory, someone using this could put it to a new folder, but ideally most people will just stick with the makefile, so that is out of the way for now. The next thing we want to do is we want to get our compiler flags. And these are what we want the compiler to be doing under the hood. And these, of course, will be changing mostly the same as they were before. So we set compiler flags, and this will equal -d -md -w all -w error. That is about it. So again, these are the same flags that we were using before, but in this case, I've specified a new one, which is md. This specific compiler flag will call into Clang to say that when we build our object files, md will output a .d file, which will contain sort of a bunch of debug information about the files. So it will tell us pretty much all of its includes and where they're coming from whenever we include this as a file, and what it's linking to as well. And this is good for the sake of understanding why some certain files may act in a certain way and why some includes may act as they are. The next one is our defines. And I'm just going to change the spacing there so that's a little bit more readable. And by default, this is something I missed out at first on our initial Windows build that I don't believe I added, but I've come in hindsight to realize is something that we'll need. So the this define here, CRT secure no warnings, this will trigger to the Windows Universal C runtime to tell it that whenever we do our includes of certain outdated functions, such as fread, fprint, and fwrite, so our file handling, it will tell the C runtime. Normally the C runtime will throw an error saying you probably shouldn't be using this. You should be, using a more modern version of this. But in our case, we still want to use that version. So we tell the runtime to give us no warnings about stuff like that. And next we want to do an if statement. So we're going to do an if eq, and it's going to be is debug and yes. What this tells us is that we are now looking to see if is debug is true, or yes in this case, then we want to add some certain defines. So in our case, we want to write defines, colon equals. We'll also include defines here. And -d underscore debug, and the one I forgot to add, -d debug. This debug is our own debug. Realistically, we should just use this one because for most Windows builds, it will still be using underscore debug. And the reason that we add the defines themselves here when we're writing to it in this if statement is so that it already expands out the list when it's assigning itself once again. Another thing to note about the colon equals here is this expands the string already rather than taking it as some kind of argument in the first place. So this actually allows us to assign it as you would expect. And that's pretty much all we're going to be doing here for our isDebug. At some point in the future, when we go through and create more defines and more ways for us to be compiling our builds, we will be adding this sort of setup here for compiler flags, linker flags, includes, extra directories we want to include, and so on and so forth, and all the other things that we'll eventually want to get around to doing. And of course, after defines, we'll also want to set up our linker flags. So here, by default, our linker flags are going to equal -l user32 -l opengl 32 and dash LGDI 32. Because by default, we always want to be linking into these libraries. And yeah, these are by default just our linker flags. We also want to add an if EQ and do the same sort of isDebug expression up here. It could possibly be optimized by making this debug check happen and then do everything that we want to change. But for now, I'm leaving it this way. But I may change that in the future. And here, we want to make the linker flags equal themselves. Plus -g plus LMS VCRTD. That's LUCRTD and LVC runtime D. Next up is our include flags. Includes are is a very short list for now. So with our include flags, we are just having this here, which is our -i, and then it calls to find our current working directory. Because of course I don't know where you, the end user and collaborator in this project, has the current working directory installed, I'm trying to do it this way so that everyone is able to find the project and compile it themselves. I could set this flag manually, but I don't want to be doing that for the sake of making everyone's life a little bit easier for now. Now, the next thing that we actually need, because there is no recursive wildcard function, which is required on the Windows end to find all of our C++ files, because some of the directory stuff that we have on Windows isn't very good as that on Linux, I would admit. So we have to, there's a definition. This one is, of course, not of my own. You may have seen this one before if you've worked with Make before. And it just is a definition that will find each, and it will just keep recursively calling into one another to find whatever you're looking for. And in our case, we're going to be using this to find some C++ files, which is cool. Our wildcard of star.cpp. So what that does is it just looks at everything from our current directory, so the base file that this is stored in, and looks for everything recursively with a C++ file. So it will recursively go through each folder and find every single C++ file. With C files as well, we will do the same thing. You can imagine this is the same, but with a .c file extension. And for object files, because another thing that is quite important to note probably, in this build, we are going to be moving to having object files and then linking to the final exe, rather than just having object files be temporarily built at our compile time and discarded. We will be keeping the object files because this allows us to then save time on the build time. Another thing that I really, really wish that I had explained a lot earlier in this video, the reason we are moving to Make, while our original build system was pretty good, it's good for what it does, it's very good for light projects. We need something that doesn't require the entire engine to be compiled every single time we want to test something out. If we want to change one thing in our main.c++ and just run the project and it just goes, having a batch file that constantly compiles the entire project every single time is just going to become a pain in the butt to deal with, I'm going to be honest. So we are moving to Make because that allows us, it will only ever update based on the last time a file was edited. If it detects a change in the file since the file was last edited, it will then say, okay, this, and this file need to be updated. If there's dependency trees that need to be resolved because one file depends on another and that file's been updated, so we have to compile both of them, it will do that. And that is the whole kind of idea behind using the Makefiles in this way. Anyway, for our object files, it's going to contain two lists. It's going to contain all of our C++ files with a colon modulus which equals our build directory %.o. What this will do is it looks at all the C++ files that we found from our recursive wildcard and expands them to equal the current bin, so the bin folder of wherever that C++ file was found at that place .o. So for this, what that means is if the C++ file main.cpp is found at main-main.cpp, it will expand it out to equal bin-main-main.cpp.o, and that will be where our object files of all of those types are stored. And we do the same thing for C files as well, since, as I said before, because we're using glad.c, we need to compile glad in our project, and there are ways that we can, compile C and C++ files, which is great. The next thing that we need to get is we need to get all the directories. So what that means is we want to get every single directory that exists in our file tree. So core-data, core-error, core-io, core-os, core-variant, main, third party, all of those, we need somewhere to place our object files. And natively, you can't just place the object file at a path that doesn't exist. So we have the first step in our compile process needs to be creating our file tree, which will be a direct repetition of the file structure here. And of course, so that we don't have to keep updating our bin file every single time we want to compile something, we have the directories command do that for us. So what it's going to be doing is it's going to be doing a lot of substrings. And when we get around to doing these, we're going to have so much fun. The first thing that we want to do is we want to call, this is actually reverse of the file, so I'm going to write the whole thing out first. This is a pretty wacky command, but I'll try to go through what it does. So the first thing we do is the most internal expression is a call to the shell, which the shell is whatever command line we're using. So by default, this will normally be PowerShell or Windows Command Prompt because we are on Windows. Big warning. If you're using something like msys2 to get your Clang, or using, it's the Pacman that comes with msys2, this may very well mess up getting make to work because make throws a fit and starts using sh commands randomly. And I had to spend forever trying to debug this issue a couple days ago when I actually realized that was what a problem I had with my code base was. Please be careful when using it. If this command doesn't work and it tells you that you're not using the dash options, I really suggest moving away from using msys2, which is really dumb to say, but it was just messing me up for Makefile specifically. Anyway, little rant over. What this will do is it will call to dir, and it'll have these commands here. What this does is it'll get a bare list of every single file or every single folder under your current directory, and it'll only look at directories. It will not output. When you expand this command, it will not output files. It will just output directories, which isn't actually always consistent on the command line, but it works in here, so I'm going to take its word for it. And the actual list that you'll get back will, of course, be in our Windows formatted list, and will also contain the current working directory. So we actually go and substring out the shell cd / and replace that with nothing. And also we look in the string here and we try to see if it's found bin folders. Because the bin directory will exist after you first compile, it will also register itself as a directory. It's not a hidden directory. It will get noticed and picked up by the application. So what you want to do is you want to say, okay, if you see the bin directory and any of the bin's subfolders, which will be created through this process, you just want to get rid of those. Get rid of every single one that is a bin folder and just delete that from the queue, because you don't want to end up with like bin dash bin dash bin dash bin dash bin, because that'll just keep appending itself like that, and that's really stupid because that's a file structure we don't need. Next up, we have a kind of a wacky thing of a variable, but this is one that I've just created because we need to use it multiple times. And this is one that just takes the build directory and appends every directory that we found to itself. So what it'll do is it'll take all of our directories, which have had their current working directory and their build directory taken from them. And then we will add back that bin prefix so that we don't end up appending bin twice. And at this point, we are now done with all of our sort of initial variables. We will now be creating our compile and linking phase. So all compile link. The basic layout of a makefile will normally have the all keyword, and that is every task that you want to run. Because sometimes you can go into a makefile and just call a specific task you want to do. So for instance, if you just want to update the linker, you can do that. If you just want to compile, you can do that. But generally, we will always be calling to do all our tasks, and we want to separate these out so that they exist in that order. So now we call to .phony compile, and then we create our compile step. What phony does, this keyword here simply says, okay, this is the only one of this type. So if we were to have two different compile things in a file, it says, okay, this one's going to be unique, and it's going to throw an error if there's more than one. And the first thing that we want to do is we want to echo, and the @ here silences the command getting pasted into the terminal. When we run this, the echo will only ever run. The echo, all it will do is it'll just run the command rather than actually like pasting the command, because that's normally how this step will work. Next, we want to check something. So Windows is a little stupid. And by a little stupid, I mean very, very stupid. In that when it runs its make directory, or the mkdir command, if the directory doesn't exist, it boots out, it says it already exists, kind of has a fit, which is a problem for our files because we just want to be able to create these directories if they exist, and if they don't exist, just whatever. So the way to get around this is that we say if the build directory does not exist, then we want to create the bin directory. And that's the end of that statement. We then do the same thing for our final directories. If one or none of our final directories exist, or if none of them exist, then we want to create them. Of course, that command only ever runs if the final directories don't exist. So if you create a new directory, this may fail. However, ideally speaking, that shouldn't always be the case. Another thing to note is that make does allow you to just have quotes here. So if we expand out this phrase here, which is called to build directory, so we get bin and then the expanded phrase, and it compares to blank. So bin doesn't exist. Then we make the directory, and the same thing here for our final directories. And at this point, we are now done with creating our bin project folder. We then want to echo that we are now compiling the project. And now you may notice something that is a little bit funny, is that we don't actually have any explicit compile commands, and we'll be getting to those at the bottom of the script. But the next thing that we want to do is we want to call again to phony for link, and link will be here. And link, because we always want to make sure that something happens before link, it will call to compile and pass all of the object files to it. And what that means, or object files. So what this means is that compile will always expect, or link will always expect the compile process to have started, and it'll also expect it to get all of the object files as well. Now, if you may notice, all of the object files have not been found. I'll get onto that in a moment. So the next thing we want to do is that we call to done. And then we say that we are now building the binary. And here we call to clang++. We take all of our object files. We say we want to output to, which is bin-victoria.exe. And we pass all of our linker flags at this point, because we always pass linker flags at the end of the process. Then we have another phony, which is clean. And what clean is going to do is it's going to all it does is it calls to rmdir and takes the build directory -s-q. And what this means is whenever we call into the into the Windows and into the Makefile to clean our directories, i.e. to get rid of all the previous object files, because sometimes in a project we may get so many object files and then all of a sudden we are unable to compile properly because of some outdated or no longer existing object files. So what we want to do is we want to have a way to remove all those object files so we can compile from scratch again. And this is also something that we would want to change, you know, if we want to test that our entire thing can build from scratch. And what this does is it removes the bin directory, but also passes these two flags, which basically say remove all the files and remove everything recursively as well if it already exists. So these just override the basic permissions that the directory is not empty, but we don't care, clear it out anyway. Now we're actually onto the step where most of the compiling efforts happen. So the way this works is whenever we want to get an object file, you'll notice here that it expands out a list based on all the C++ files we found and all of the object files. Now, of course, our object files, well, we haven't made any yet. There's no command that puts out a core-main.o file. And this is the part of the project where this happens. So down here, we want to set our first target, or one of our first targets in terms of things that we want to compile, which is to %.c. And what this does is it basically says that one thing that we always require is we want to create a bin dash wherever that C file is of .c.o type, which will depend on wherever that type or where that file name .c exists in our project. And this goes for whatever type we're talking about. And here we're going to echo. What this command here does is that pastes in, this says, okay, well, we want to space this out. So we say what files we're compiling, and this will just say, this will paste in whatever file that is, which in our case, that could be main-main.cpp. And then here we actually make our call to clang++ of -x C++, because again, we want to treat our C files as C++ files in this case. And again, that will say of the current type, and we pass in our compiler flags, -c -o $at, which means to whatever this is set to. And then we include our defines and our includes. And we do pretty much the same thing here for C++ files, except that, of course, because we don't need to say the -x C++ because it's already a C++ file, we just do that. And that will eventually do what we want it to do. And then now here we say -include object files :o equals .d. And that just tells it to include all of the object files and their debug correspondence, because the debug correspondence should have been created. Now we need to do a couple more things. And one of those things actually lies in our .batch file. We now need to sort of rewrite this to do what we want it to do. Now, unfortunately, that does mean most of this is going to go. So we're not actually going to be building the executable. There's going to be no option to do this. And there are a couple of things that we are now going to add into our project. So the first thing is we are going to want to detect if we have clang++. The where command tells us wherever the executable, which is this name, is stored, and the -null just sends it to a null stream, which means that it doesn't print to our terminal because it'll normally print a file location and we don't want to have that information in the terminal. And then we say if %error level is NEQ to 0, then we want it to do something. And in our case, because it cannot detect clang, it's going to abort because it's realized, hold on a minute, you don't have clang installed, then there's nothing that, we need to make sure that clang is there. So we're going to leave. And we do the same thing for make now, where it looks for wherever make is on your system. And if, of course, the error level is not equal to that, then we abort. And the last thing that we do is we call to makefile.windows.mac all is debug equals yes. And that's pretty much the entire layout of our new build file. What this will do is it will get all of our debug files and our object files, and it will just do everything as is. And that now means that we can save time by not having to recompile the whole engine whenever we want to make a change. But there are a couple other places that we do need to make changes. We also want to add another file, which will go under here. And this is our clean.bat. Because if you'll notice from our build.bat, there's no option to clean. And here we will add that option. Again, we'll do the sort of the same thing. Where we look for where make is. Realistically, we could do a clean option here, but regardless, I'm going to call make to makefile Mac, and we're just going to call to the clean step. And that's pretty much everything this file needs to do. However, we do need to update our tasks to now reflect our new task that we can run. So you want to put a comma here and open up a new one. Its label is going to be clean binaries because that's what it's doing. Type, it's a shell. And on Windows, well, Windows is just going to run from the workspace folder, clean.bat. On Linux, it's going to run the same command for workspace folder, clean.sh. We haven't actually created the Linux version, but that's what it will do. And our problem matcher is going to be GCC. And that is pretty much the only update we need to make here. Now, what we can test is we can now quickly hit Control-Shift-B. And you should now see that a whole bunch of compiling now happens, and now it builds the binary. We do get this linker warning here that default libs, libcnt, conflicts with the use of other libs, use -- no default lib library. That warning can basically be ignored. So far, I haven't had any errors come of it. But that will be the entire project now done. We now can use Makefiles. Boom. Now for the Linux Makefile, we are going to be creating, of course, in a very similar sense to the Windows Makefile. In theory, you could combine both of these to make one Makefile, but for now we're keeping them separate just because of the way that the platform stuff is going to work. So rather than explain what every single part is going to do, I'm going to do a copy and paste here. You'll notice that pretty much all of the original things are basically the same, aside from the actual arguments. So here we don't actually have any prerequisites to the defines, so we just pass debug. And here we have our linking libraries as well. I believe our original build did not include, it also links to XKB, which in this makefile we are no longer linking against, we are now linking to X11. But we are also linking to the GL libraries so that we can use the native OpenGL functions that exist on Linux. Next up is all of our files, so we'll just paste these in here, and I'll just move this one down a line because for consistency reasons, and you'll see they're more or less the same again, but here we can use our -type thing here because the Windows shell does not support find in this manner because, of course, this is the Linux type. And we do the same sort of thing here as well. And all of this has been updated to actually reflect that. And then we have our compile linking phase. So we create our directories. We then get all of our object files and we build those. And we also have our clean option, which of course is just to remove all the files that exist and all of the directories. And the last step then is just adding these. And again, these are pretty much the same. There's no real changes between any of these. I'm just sort of adding as I go along. And in terms of Makefiles, that is the Linux side of the Makefile setup. But now we do have to make some changes to our shell files and our shell scripts so that we can run them properly. So we are actually going to grab all of this and replace it with this, just so that the changes reflect what has happened. And what by that I mean that we now check for clang and if make doesn't exist and if there's any errors as well. So all of these are now created. And we sort of basically have the same thing here for our clean.sh file, which we actually need to go and create. And just copy and paste in there, and we'll see that it does more or less the same things as we would expect. So that's pretty much everything in terms of getting Makefile support in now. So from this point onwards in the project, everything we'll be using Make. And if we ever build libraries or test applications or anything, those will also be using Makefiles rather than using general compilers, just because Make allows us to not have to rebuild the whole project every time. And that will get very expensive as the project gets bigger and bigger. But aside from that, thank you very much for watching. I hope you'll enjoy episode 6, which should be the next video that comes out very, very soon. That will, of course, be, as I mentioned previously, that will be on our event system, and that will probably be a fairly short video, but I do want to go over the sort of idea behind it and what we can do with it further on. Anyway, thank you very much for watching, and I'll see you in the next video. Goodbye.